Welcome to our HAKOM TSM Data Pipelines overview. In this short presentation, we will cover how the TSM framework handles data flow from both classical and streaming sources. We begin with a common data processing challenge in the energy sector. We call it the energy data jungle. Here we have many different sources of data, various databases for storing the data, and at the bottom, various applications. Most of those applications depend on data coming in from more than one source in different formats or resolutions. And some of them also need to be processed in near real time. Our solution to this growing jungle is built upon our time series fabric, which sits right in the middle. It harmonizes and validates the data and thus makes it much easier to handle very complex use cases. But what we do not see here is the way the data is flowing, and this can in some cases be decisive. Is it still possible to manage the data flow simply by batch processing it, or is it necessary to stream the data in near real time in order to not get any bottlenecks? The answer, of course, is it depends. It depends on the applications and its requirements. But most certainly we need a path for the stream of continuously flowing data. To put this in context, we begin with an overview of the HAKOM TSM framework architecture. This diagram depicts how it interacts with upstream sensors and downstream applications, clients and processes, which you see on the left side, as well as with various persistence options that you see on the right side. Our service is placed right in the middle, with various features highlighted. If you're interested in more detail, be sure to check out our webinar, The Backbone of the Data-Driven Energy Industry. I'll make a note here that our domain layer is actually composed of a number of stacked components. That is to symbolize that it runs on scalable resources, which can be, for instance, a virtual machine with multiple cores, or more likely a number of containers in a Docker or Kubernetes environment. Now, the important thing here is that the value of the service lies precisely in that it abstracts the data model and storage layers to the outside world. It is a fabric connecting the elements, and with it, a client application or a device sending data doesn't need to know what will happen after the data is transmitted, since our service takes care of that. Now let's put this in a slightly different form to better illustrate the data flow. The elements that were before on the left side are now spread on both extremes of the slide. On the left, we have those elements generating data, and on the right, those applications, platforms, and dashboards, which are the consumers of the data. Typical solution architecture involve tools for the ingestion of this data, dealing with monitoring what is taking place, a schedule of when to pull the data from which source, and perhaps according to different parameters or attributes, so the metadata in general is deciding how to proceed. This ingestion tool will then feed the data to our API, which deals with transformations, unit conversions, or resolution adjustments, but also all the aspects related to data quality. This can be cleaning the data, creating replacement values when some data points are missing, or maybe automatically correcting outliers. This is then fed onto the actual API for storing the time series values. This deals with identifying what time series is stored where. Maybe different databases are used in a hybrid environment where some storage is on-premise, but other resources are in the cloud. This means actually the data storage icon here should be multiple icons, but that's transparent to the outside world. Finally, the API exposes endpoints for the outside world to get hold of this data. The applications on the right side submit queries asking for time series data for certain time periods and get the data in whatever resolution, unit, or aggregation level they desire. There is, however, a new paradigm for data flows, and that is streaming. You can imagine a river of data continuously flowing with applications at the shore, constantly collecting data, but also pushing new streams onto the river. And the good news is we can keep our existing components, but simply change the way in which they interact with the data. Let's say our data sources are now all streaming their data onto the selected platform. We skip the batch step and instead allow our transformations to latch on to the ongoing stream. So we have a subscription from our transformations customer, which deals with those conversions and cleansing steps I mentioned before, and they again push their output back onto a new stream topic. And this topic can again be subscribed by a dedicated time series consumer, the time series subscriber, which works as the interface to pipe data from the stream to the API for persistence or other tasks such as analytics. And this way, it is again available to all the other applications to query it through the usual means. And now for a conclusion, we can put the two paths back together and realize the very same components can fulfill their roles over two different paths, the hot path of data streaming as well as the cold path for batch processing. This gives you a lot of flexibility in deploying the services in a range of scenarios without having to reinvent the wheel or develop the same functionality twice. This ensures that transformations are consistent and that there is a unified view of the data, which is exactly what we want to achieve with a universal time series fabric. Thank you for watching, and don't forget, life is a time series.